For centuries, humanity has gazed at the stars and dreamed of exploring the cosmos. Today, that dream is closer than ever thanks to groundbreaking advancements in space propulsion technology. We are on the cusp of a new era of space exploration, one driven by the incredible potential of plasma propulsion. This revolutionary technology promises to transform space travel as we know it, enabling us to venture farther and faster than ever before. Imagine a future where we can reach Mars in a matter of weeks instead of months, where asteroid mining becomes a reality, and where interstellar travel is no longer a distant fantasy. This is the promise of plasma propulsion, a technology that harnesses the power of superheated electrically charged gas, known as plasma, to generate thrust. Unlike traditional chemical rockets that are limited by their fuel efficiency, plasma propulsion systems offer a far more efficient and sustainable way to explore the cosmos. Traditional chemical rockets, while having propelled us to many milestones in space exploration, are fundamentally limited by their reliance on chemical reactions to produce thrust. These rockets carry vast amounts of fuel, which makes up a significant portion of their total weight. This inherent inefficiency means that a large amount of energy is expended just to lift the fuel itself into space. The limitations of chemical rockets become even more apparent when we consider long-duration missions to distant planets like Mars. The sheer amount of fuel required for such a journey, coupled with the need for a return trip, poses a significant logistical challenge. Additionally, the relatively low speeds achievable with chemical rockets translate to long travel times, exposing astronauts to prolonged exposure to the hazards of space. Plasma propulsion, in contrast to traditional chemical rockets, offers a more elegant and efficient way to travel through the vacuum of space. Instead of relying on chemical reactions, plasma propulsion systems utilize electromagnetic fields to accelerate charged particles, creating thrust. By heating a propellant, typically an inert gas like xenon, to extremely high temperatures, we can strip electrons from the atoms, creating a plasma. This plasma, consisting of ions and electrons, is then channeled through a magnetic field, which accelerates the particles to incredibly high speeds. As these charged particles are expelled out of the spacecraft, they generate thrust, propelling the spacecraft forward. This method of propulsion, while not producing as much thrust as a chemical rocket, is far more efficient in the long run. The development and refinement of plasma propulsion technology hold immense promise for the future of space exploration. With its potential for high efficiency and faster travel times, plasma propulsion could enable us to reach destinations within our solar system that are currently beyond our reach. Imagine a future where crewed missions to Mars are not only possible but routine, where we can mine asteroids for valuable resources and where we can send probes to explore the outer reaches of our solar system and beyond. While there are still challenges to overcome, such as scaling up the technology for larger spacecraft and developing more powerful and compact power sources, the future of plasma propulsion is bright. As we continue to invest in research and development, this transformative technology has the potential to usher in a new golden age of space exploration. One where the boundaries of the cosmos are no longer a limit but an invitation to explore the vast unknown.